In problems 15 to 18, we're going to do problem 15. Find a vector P1 that goes from P1 to P2 and graph P1 and P2 and its corresponding position vector. So usually with the P we indicate a point, and we can confirm that from the fact that they have round brackets. So we know these are not two vectors, these are 2 points. So if I want to go from point 2 to, well, if I want to know what is a vector? A vector is the distance that you have to travel to go from A to B, right? Or that's one way to think about it. So if I have a point 1 and a point 2, to answer that question, I will have to say, well, the final minus the initial, P2 minus P1, and then that's going to give me, if I subtract component by component, that's going to give me a vector. So what is P2? P2 is 5 and 7. And P1 is 3 and 2. Now this is the step that you have to remember. Now this becomes a vector, and you say 5 minus 3. So you say the component of P2 in the x minus the component of P1 in the x, and then the component of P2 in the y minus the component of P2 in the y. The component of P2 in the y minus the component of P1 in the y. That's going to be equal to 5 minus 3, which is 2, 7 minus 2, which is 5. Now let's see visually what that means. So let's say we have an axis system, and let's say these are our x-axis and this is our y-axis. Or actually, a better way, let's say this is our i-hat axis and this is our j-hat axis. If I were to plot P1, I'd plot it at 1, 2, and 3, and at 1, 2. So I'd plot it here, P1. If I were to plot P2, I would plot it at 5, so 3, 4, and 5, and 7. 2, 3, 4, 5, 6, and 7. So that would be right here. That would be P2. Now, you want to find this vector right here. You want to find a vector. P1, P2 means from P1 to P2, like this. Well, to find a vector of P1 from P1 to P2, so let me just make clear, this is the vector P1, P2. You want to find the components of that vector. Well, guess what? The components are made up of vertical and horizontal because we're dealing with 2 dimensions. So, how would I find this yellow? Well, it turns out that this yellow will be, oh, sorry, that's not yellow, but anyway, it turns out to be this whole length minus this whole length. Okay? And we know, so we are trying to look for the orange, but we have this length right here. So if I take this big length and I subtract this small one over here, I get what my orange is. And this big length is the y component of P2, because that's how we define where P2 is. So to find that length, I would just need to do the 5, sorry, not the 5, the y component of P2, the 7, minus where we start off, which is the y component of 1, of P1, which is 2, minus 2. And so we know that this has to be 5. And as you can see, the y component is 5. That is the same for the x direction. Now, they're saying graph this vector and its corresponding position vector. Bonus question, what is a position vector? What is just a vector that starts from the origin? So you'd have to imagine taking this vector p1, p2, and graphing it again, and I'll do it in this color. You want to graph it again, but now you want to graph it starting from the origin. So you'd have 1, 2 here, and 1, 2, 3, 4, 5. Is that 4 or that 5? I think I made a mistake here. We want to get 1, 2, 3, 4, 5 here and here. So that would be your corresponding position vector, because now the coordinates of this vector also give me the position of the head, and that's why it's called a position vector. So the position vector is not the same thing as p1, p2. The position vector is the specific equivalent vector to p1, p2 that's starting from the origin. All right, see you in the next one.